Testing polar equations for symmetry. What kinds of symmetry polar equations can have? In polar coordinate, the points r theta and r negative theta are symmetric with respect to polar axis, or as we say, x-axis in the rectangular system of coordinate. There we go. Okay. The second case of symmetry, when we have points, coordinate r theta and r pi minus theta are symmetric with respect of the line theta equal half a pi. Which is going to be half a pi. Okay, which is, and that is y-axis. And lastly, we have points. The points r theta and points negative r theta are symmetric with respect to the pole, which is origin, right here. All right? So here we have at the r theta, this opposite direction, we have negative r theta. Okay, so let's summarize the test for symmetry. So the symmetry with respect to polar axis. Symmetry. Polar axis or this is x-axis, right? So, in a polar equation, we are going to replace theta, replacing with negative theta. And if the equation gives us same result, then the graph is symmetric in respect to polar axis. Okay. And second one, we symmetry in respect to the line theta is equal pi over 2, which is y-axis, right? So, in polar equation, we replace theta with pi minus theta. And if an equivalent equation results, which is we get same result, then the graph is symmetric with respect to pi over 2. Y is equal pi over 2. And lastly, respect to the pole, symmetry with respect to pole, which is origin, we are replacing r with negative r, or we are replacing theta by theta plus pi. Well, let's look here on the last one. See if it's create theta. This is our theta, right? This is our angle theta. Okay. And we are doing plus pi. Okay. So this is the symmetry with respect to pole. Okay. So these free tests for symmetry are sufficient conditions to consider that graph is symmetric, but they are not necessary conditions. So some equation may fail this test and still have a graph that is symmetric with respect to polar axis, with respect to theta is equal pi over 2, or with respect to origin, which is a pole. There are some graphs. For example, r is equal sine to theta. R is equal sine to theta. Okay? It's turned out to be symmetric with respect to polar axis, the line theta is equal pi over 2, and pole. But only the test for symmetry with respect to the pole will work. If we use this method, theta replaced with theta plus pi. Only this way will work. Okay? In that case, you might wonder then, what this test of symmetry is good for if it's not satisfying every time. So what's the point to do that? And the point is, so whenever satisfy any polar equation satisfy the condition of symmetry, then we know definitely that there is going to be symmetry in graphing, and it's make our life easier. So its graphing would be easier because we are confident that there is a symmetry. But when not every condition satisfies, then still could be symmetry, we don't know. Then I guess as we plot by points, we'll find out. Okay? This is the point of testing, and it's still, you will be surprised how much it helps when the conditions of symmetry satisfied. Okay,